Hi, everybody. My name is Tom Ammon. I've worked with the Packet Pushers a few times. I'm a network engineer, network architect. Been working on enterprise and service provider networks for a while. So my presentation today is about a thoroughly unsexy and not really a complicated topic, but it's something that I think the industry needs to hear. So. What I want to talk about today is network maintenance. How do you do it? How do you do it in a way that can enable what you're doing in a way that doesn't disrupt the business and doesn't break the business? And what are the things that we can do to make network maintenance work well? And how can we become an engineer who has a reputation for not breaking stuff? I think is the big thrust of what I'm talking about. I want to start out by saying anybody who's listening or hears this later, if you think I got something wrong, let me know. Engage with me, public or private, social media, email, whatever. Would love to discuss the things that I got wrong. I am not infallible, and would love to get some new ideas. So I'm definitely open to being corrected if I need to be. So I want to go through a little bit of scoping for the presentation. So first of all, what am I talking about? So when we talk about network maintenance, I'm specifically not talking about ITIL. I'm not talking about whether its suitability to handle the complexities of modern networks. I'm just not talking about that. I have opinions about it, but that's not what we're doing. I'm also not talking about spectacular failures that were caused by maintenance. We've had a few of those recently. Our industry has a long history of these kinds of things. If you want to see that, I've got a link there in the slide. There's some great post-mortem lists out there that can help you learn from other people's spectacular failures, but we're not going to talk about it today. But what I do want to talk about is how do you plan and execute a flawless maintenance window? I probably should have put an asterisk there because our work is so complex. Flawless, I don't know. It's challenging to do anything flawlessly in our environments, but that's the goal. That was my inspiration for putting this together. Who am I talking to? I'm not looking to give a message to change control people or anybody else who's trying to find something to beat network engineers over the head with to make them be more disciplined or something. That's not who I'm talking to, but who I am talking to are the engineers who aspire to craftsmanship. If you're somebody who wants to be known for doing good maintenance and keeping things stable, then you're my audience. And also, I'm talking to hiring managers, people who are looking to bring engineers onto their teams. Over the course of my career, I've seen a various different managers work for various different managers, and I see that there's a lot of stuff that goes on in the hiring process that I think this presentation may help. It's a different skill set to design and architect than it is to operate. In my mind, they're both very critical skills, but they're different. And just trying to find the smartest engineer you could possibly find seems to be the norm in the industry. And I think that there are more specific personality attributes and work ethic type things that you can filter for that I'm hoping can be exposed in the things I talk about today. Okay, so why would I give this presentation and why would you care? Really two reasons. The criticality of our environments is going up, up, up. The stuff that we're being asked to do is increasingly integrated with the business, and we can't afford to ignore it. But simultaneously, the complexity is increasing. So it's not just that it's becoming more critical, it's becoming more critical and more complex at the same time to operate our environments. I think that's going to require more of us than it has in the past. And the other thing is, my personal belief is that programming languages and tools and tool chains are not going to save us from what's in our future. I'm not saying you shouldn't learn Python. You should. I'm not saying you shouldn't become some sort of a developer, and I'm not saying that you shouldn't learn tools. You should, but those things by themselves are not going to save us.
You're a heretic, Tom. New shiny things will always save us.
But if you put some good reasoning in front of those things, I mean, if you back those with good sound thought processes and good engineering thought processes, those tools can multiply our effort. But by themselves, they're not going to get it done. All right, so how? My method here is basically to give you a tool that you can use, one or two tools. I'm going to expose 6 of them that I found in my career. But really, this is a full toolbox. I'm sure that there's a bunch of other principles I'm missing. So I'm going to pull out a couple of the shiny tools that have been useful to me. And as you know, as the maintenance that you undertake becomes more complex, you have to use more tools in order to do it right. Some things are simple enough. All you need is a hammer. Some things are simple. Some things need more things, more tools, and more approaches. And so, but basically, what I'm trying to do is from a first principles standpoint, say what are the principles that undergird a successful maintenance. So these are the tools that I want to focus on today. Get and communicate context, planning, how do you plan a maintenance window, peer review, execution, validation of your changes, and then in the end, discipline that you impose upon yourself as an engineer.
Validation, that's overrated. Sorry, anyway, we'll get there.
Yeah. So the first question you have to ask when you're preparing for a network maintenance is, why are we doing this in the first place? And it really depends on your role, how to ask this question and who to ask it to. But really what you want to find out, you want the big picture. So, why does the business need technology, whatever. But you also need some more detailed why. Why are we using this routing protocol? Why are we moving to it? Why are we moving away from the old one? Why are we doing this L2 configuration? Why is this load balancer change required in our environment? If you don't have these in your mind, it's going to be hard for you to construct the checklists, which we'll talk about in a minute, that will help you to know that you are successful. So understanding why is a big deal. If you're an architect who's executing a change, some organizations are built like that, that's probably pretty easy to find out. But if you're not, if you're someone who doesn't do network design, but who is still expected to carry out network changes, you're going to want to obtain this knowledge from whoever it is, from the architect, from the management, whoever happens to have this knowledge. You really should start by asking the why questions. And then the other thing is, what comes next? Okay, what's after this maintenance? Is this part of a bigger plan? Is this something that is going to enable another maintenance? How many dependencies do we have? Is this the first in 5 or 10 maintenance windows? You can get a sense of the criticality of this particular maintenance, and that can be helpful. So you got to ask all these why questions and what next questions. So that's the get context part. So you got to go talk to a bunch of people.
Tom, a quick question. Yeah. Are there tips or ways that you can, sometimes when folks get a question, it seems like a challenge, like I'm doubting you, or why are you bugging me with this information? Is there a way to do this in a way that's not hostile or aggressive, that's going to actually elicit useful information and not, I'm trying to debate you and prove you wrong, or just give you more work to do?
Yeah, thanks. That's a great question. And this, admittedly, this requires a little bit of emotional intelligence to ask the why questions. What I've found helpful is basically, if you just approach people in good faith and communicate to them that I want to do a good job, I don't want to break things, I want to make sure that whatever it was that you want to happen in this infrastructure is happening, that can be pretty disarming to people. That can show people that you're really just trying to do a good job. I think most people, almost everyone I've ever worked with, once they get a whiff that I'm really just trying to do a good job, they'll tell me pretty much everything I need to know. So I think that's the approach I take. It's not just about getting context, though, because as the person executing a maintenance window, you have to communicate it. So who do you communicate it to? And this is just my quick drawing of the sorts of interpersonal relationships. These are all people in this diagram. The sorts of interpersonal relationships that engineers, specifically engineers who implement network changes, might have. And your organization may be different. It probably is different. The links between the different groups might be different. There might be common management between the NOC and engineering, et cetera. But what I was trying to illustrate here was that the person implementing a network change, just because of the centrality of the network infrastructure, really is in the middle of the action. You have the opportunity to be connected to all different parts of the infrastructure teams. And you should use that to your advantage. It can help your career, but it can also help the success of your maintenance. And I'm not saying you have to go do a communication plan with all these people. I mean, at some point you have to actually plan the work and do the work instead of just talking about the work. But these are the people that you should consider when you're figuring out who to communicate with and how to communicate and things like that. If you think about all these people, I guarantee you're going to be more successful in what you carry out, especially in the big complex changes that you undertake.
2 cents to add there, Tom, to the vendors notion. I have had success notifying a vendor that, hey, we're about to make this change. Will you guys be there to support us if things go south during the change? And if you're a significant enough customer, they'll be there for you. They'll actually have someone on call, possibly to support your change.
Yeah, absolutely. The preemptive TAC or technical assistance case is a gem, and we shouldn't think of it as some engineers think of that as, well, I failed somehow if I get the vendor involved. No, I mean there's some complex software going on under the covers, stuff that you even if you were able to comprehend what was going on in there, which I don't claim I'm able to comprehend everything that's going on inside a box. Even if you could, it's not available to you, and so there's no shame at all in asking a vendor to help. Now, if you've got some pride as an engineer, you're going to want to exhaust all of your options first, but that doesn't mean you can't get them on the phone. And that's one thing I hope that we can lose, is this idea that I'm somehow have failed if I couldn't do the work all by myself. I don't think that's true. So thanks. That's a great point, Ethan. All right, let's talk about the plan then. When you're planning a maintenance, what do you have to do to be successful? And it turns out it's pretty simple. I want to tell a little story here that I read about in a book, and I'll show you the book in a minute. The year is 2001. The hospital is Johns Hopkins Hospital in the United States. And there was a doctor named Peter Pronovost. Hope I pronounced that right. He had a problem to deal with, and that's central line infections. Now, basically what a central line is where, for whatever reason, the doctor deems that they need to deliver medicine directly into your heart for whatever reason that is. And the way that they do that is they stick a catheter in your jugular vein and shove it down inside of your chest to the valves of your heart. Sounds lovely. I've never had one, hope I never do. But the problem that he had with this procedure is infections. There were some hospitals that had horrible rates of infections with these, and many of them leading to fatalities in the hospital. Somebody came in to have a procedure done, they needed to have a certain medication, and then they died. So this is a significant problem. So it engaged the intellect of Peter Pronovost, Dr. Pronovost. And so his big idea was, well, let's have a checklist. They had, the culture they had was that, and that many hospitals still have, is that the doctors are the top of the heap. Nobody can tell them what to do. After all, these are the guys and gals who have spent many, many years educating and training themselves to do a good job, and they're experts. And so nobody could really tell them what to do. But the hospital said, okay, we'll back your idea, and we'll even give the nurses authority to tell the doctor, if you don't follow the checklist, you can't perform the procedure. So the nurses this was the big change. The nurses could tell the doctor, no, follow the checklist. And this was the checklist. It looks pretty simple. Wash hands with soap, then clean the patient's skin with an antiseptic, then put sterile drapes over the entire patient, then put on a mask, hat, sterile gloves, and then put a sterile dressing over the site of the central line insertion. That's it. That checklist is pretty simple, 5 steps. They watched, before they started the experiment, and 33% of the procedures, the doctor skipped one of these 5 steps. Now, if I'm going to that hospital, I don't want him to skip the put a sterile dressing over the insertion site part. Right? I don't want him to skip the wash hands with soap part. I really don't want that. But it was happening. And it's just because humans are fallible. It's not because those doctors weren't very well trained and well educated. So this was the checklist. So what happened? So they had an 11% infection rate. After 1 year of using the checklist and enforcing it, they had 0 infections in the hospital. So they kept watching. They said, this is too good to be true. There's some kind of fluke. We got to do the experiment again. So they watched for 15 more months, and they only had 2 infections total in the entire hospital, in the entire, almost 2-year span. And then the outcome they measured after they got finished was, they estimated they prevented 43 infections, that they saved 8 lives, and they saved $2 million in cost. So I like this example. It's really dramatic. It shows the power of the checklist, that if you do the things that you need to do in the order you need to do them, and if you are disciplined in following it, outcomes can be extraordinary. This story came from a book called The Checklist Manifesto. Many of you may have read it. I highly recommend it for anybody doing network operations, and it's a good read. He tells a good story. Okay, so how does this affect, how can we translate this into a network maintenance? So this is sort of an outline. There's probably things missing here, but if you go through this, and this is sort of a checklist, but the idea is that you build a checklist of your own for every maintenance. And here are some things that you could put into your checklist. You could document why this changed. This is just a writing exercise to help you go back to the get and communicate context part. You can list the customers affected so that you know to notify them if you need to. Which personnel resources are required. Sometimes you're going to need somebody in the data center to go run cables for you, or rack a box or whatever. What are the nodes that are affected? What are the nodes that are configured? As you think about this and catalog it in your mind, you can start to understand what the blast radius is around a potential failure in your maintenance. It helps you to be prepared. It not only makes sure that you configure the right things, but it also gets you in the right headspace for when a problem happens during the maintenance. You already know what's going to be affected because you documented it in your checklist. And then a baseline. So you take a baseline before the start of the maintenance, and a baseline is really just what does the environment look like. And we'll talk about some more details when we go into the validation portion of this. We'll talk about more details about what could be in a baseline. The exact configuration commands for each step. I'm a big fan of this because if you're copying and pasting commands, at a minimum, if you're copying and pasting commands, you're a lot less likely, it goes faster and you're a lot less likely to make human error. Next on the checklist, understand what's going on with the control, management, and data planes, and how are the network devices affected. If you make this change, are you going to lose SSH access to the box? Then you need a console in. You want to know that in advance of the change. You don't want to find that out in the middle. What happens in the management plane? What happens there? What happens to the control plane? What happens to OSPF when you start making these changes? Are the neighbors going to go down? Are they going to stay up? Are you going to try and do it fast enough that nothing happens? Next, you need to understand how are applications affected. So at some point, depending on how big of a change it is, you're going to want to know when I drain traffic off of the side or the site or the data center, what's going to happen to the applications. The act of draining the traffic might do something to the applications that you would want to know about, and understand how that affects the application. And I realized that one bullet point there, you could spend many, many hours figuring that out, and maybe you can't. But the idea is just understand what the environment is like and what's going to happen. Think about what's going to happen before it happens. A validation plan, you need to have that in place. How am I going to make sure that I did what I intended to do and that I didn't break anything? And then a rollback plan. Now this part's really hard. By the time you get to this part in the checklist, you're tired mentally. Probably been working on a change, big complex changes, maybe been working on this for a couple of weeks. I don't want to go back and figure out how to roll all this stuff back. But you need to, because when something really bad happens, when the change doesn't work and you don't understand why, you have a duty to protect the business. And so you have to be able to roll back, and then you have to have a validation plan to know that your rollback worked. So,
if I wasn't on camera and feeling really silly, I'd be like jumping up and down and applauding and stuff right now. I'm just thinking back to different experiences where, yes, you just had to have all of these things and understanding what's going to happen at each step along the way. I'll summarize this for me. I love this slide, and for me, it is, I don't want to have to think too much when I'm actually in the change. I want to have done all the thinking already and have the plan in front of me that is my sanity, that I follow closely and know where I'm at and know what's happening as things go along. If for no other reason, so often the changes that I would end up having to do, they're at 2 in the morning and I'm tired and I don't want to rely on my intuition and my mental alertness to save me. I want to rely on a plan that's been thought through. So I'll let you go, Tom. Sorry, but yes, I love this slide. It's great.
Yeah, thanks. And the other beauty of the plan is that you can hand it off to somebody else if you need to. There's just a lot of benefits. But really, if you don't skip a step, then you get the same sort of outcomes that those doctors got in the Johns Hopkins study. And that's what we're after. All right, so you've done all this. How do you document it? Really, my main factors for success here is it needs to be something with version control. You could accomplish it with Word and track changes, I suppose, if you're into that sort of thing. Or you could do, probably what you want is some sort of plain text format. My favorite here is Markdown with Git, because Git gives you all the collaboration features, all the peer review, all the code review, all the workflow. But whatever it is, you need to have a common document format that the team uses, that everybody knows how to interact with, because the team needs to have a standard way of approaching these things. And then finally, the document needs to be available to everybody who's going to be involved. And that means to be everybody. It means to be the people in the NOC, the management, the vendors, maybe not the vendors, but it just needs to be well understood what's going to happen. That way everybody knows what's going on. And that has a lot of side benefits, which we'll talk about in the execution part. Peer review, in my mind, there are basically 2 models for how to accomplish peer review. You have the audit style and you have the collaborative style. The audit style is basically you hand your change to somebody, you don't tell them anything, and you say, look this over, make sure I didn't do anything wrong, make sure it's good, and then I'm gonna go execute it once you give me the okay. This is a great vehicle for simple changes, because basically what it requires is for the engineer to rebuild the change from the ground up, right? They look at what you've done, they go validate, they go log into every device. Did he get all the VGP neighbors? Did he get all the IGP adjacencies? Whatever. It is extremely expensive to do for complex changes. Just the number of hours required, the audit style, and it leaves so many of the benefits of peer review unused. Audit is great for simple changes, but I would argue if you're using the audit style, then you're probably better off putting your effort, the organization is probably better off putting their effort into automating such things, because if it's a simple, repeatable thing, that's simple enough to qualify for the audit, then a machine ought to be doing it anyway. But that's one way to use that. It's not an inappropriate mechanism, but I wouldn't use it for large, complex changes. And then the next one is the collaborative style. So basically, this is where you have a big, complex thing to do. You build the change with your teammates. You together collaborate on the document and figure out everything you're going to do for all those steps that we talked about in the plan. This is another place where Git really shines. You can go through, do a first draft, create a branch, ask someone to do code review, even though this is not code that we're writing. It's still just plain text. Your teammates can log into the whichever Git server you're using and put in their comments, and you can go back and forth and edit the document. Collaborative really is, the peer review is me sitting down with my peer, building it together, us putting our minds together, not unlike pair programming, if you ever read about that, to make sure that what we're doing is not going to harm the business and is going to achieve the desired outcome. And you probably still need some sort of technical sign-off from somebody. You maybe need a third person, but your chances of them finding a problem are much lower when you're doing a collaborative style. And on the largest, most complex maintenances I've ever done, where they're me and 2 or 3, sometimes 3 is the biggest I've ever done, 3, so there's 4 senior engineers working on these big, gigantic global changes. I could not have accomplished them, could not have done them if I had just built this and asked somebody to look it over. It's just too much config and too much work.
You want other people involved in this, if for no other reason than to just catch your mistakes, the things you didn't think about. You really do. Don't let your ego get in the way and think, I got this, I can do this, and just, charge your way through it. You really want other people involved, and the more complicated the change, the more you want other eyes and other perspectives. People who aren't you will see things that you don't see. So there's a huge amount of value in this peer review.
Absolutely. So let's talk about ego. So who are your peers? So you might think, well, I'm a senior network engineer, therefore the only people who really can do a good job at reviewing this are other senior network engineers. I don't think that's true. Your peer is basically anybody who can find your screw-ups. And you'd be surprised the number of junior engineers that can find a senior engineer screw-up. Sometimes they're better equipped to do it than the seniors are. And what are the scenarios where you could do somebody else besides a senior person being your peer? Now, I'm not against other senior engineers reviewing your work if you're a senior, but here's some examples. Somebody who just passed a certification exam, say your change is focused on routing and they just passed a certification exam focused on routing. That's a perfect person to review your change because they just got their nose out of the book. So the things are on their mind. The academic stuff is on their mind. They're more likely to find problems. A junior engineer can help you, in my experience, if they have an interest, not only, but if they have an interest in the technology and learning the technology you're deploying, they're going to be extremely valuable because they're motivated to understand why. They're going to ask why a lot, probably. And that's a double benefit. It gives you a chance to mentor somebody in a small scenario, and it gives them a chance to learn the technology. And I think most of the engineers I've ever talked to, the only way you really get expertise in this field is by doing it. And so you'll be lifting them. You'll be helping them move towards senior status by doing it. You have to persuade them in most cases. Most of the teams I've ever been involved with, peer review is a voluntary process. You have to build rapport with your peers and say, hey, please come review my change. So you've got to, have the emotional intelligence to do that and persuade someone to come help you. But it won't be hard if the junior is interested in the technology. Some places I've worked, there's the role of a SME, a subject matter expert. So, and sometimes they rotate that. So, you've got the load balancer guy, you've got the DNS guy, you've got the core routing guy. And if this person was the SME of the thing you're working on in the last rotation, then his brain's had some time to rest, and he might be a great resource for you, he or she. And then the other thing that can be really valuable is somebody who ran this technology, but not at your company. They ran it in their last job. That's also somebody who could be a great peer reviewer. They saw it in a different environment. They saw different aspects of it. And you can get into some great discussions, and they can find your problems for you. My last bit on this is to managers. If you're a manager, just my advice, keep your hands out of the peer selection process. Let the engineers figure it out themselves. Don't assign people to do changes. Just don't do it. You're taking away the engineers' ability to build their own interpersonal networks and really let them do it. I mean, obviously there are boundaries for this. If you've got someone who's trying to rubber stamp something and sort of, hey, just go say yes to this change, and you need to take care of that, obviously, but do your best to just keep your hands out of it. The engineers need some room to work. On the note of advice for managers, this is, for me, peer review is a huge tool to build culture. Managers have, they have a challenging job, but we need to understand, as managers, you need to understand what happens when you measure something. The saying is, what gets measured gets improved, but how does it get improved? This is my personal belief of how this works. Measurement incentivizes behaviors, and behaviors drive culture. And so if you want engineers to do peer review, then you have to create incentives by way of measurement that make that happen. And so what do you measure? Well, you could measure number of defects somebody found in a change. Well, that could be good, and it could also go south on you. You could end up creating a toxic culture where people are one-upping each other, and I've seen that, and it's not good. You could say, okay, well, what's clean? What was a good clean change? How many good clean changes did you have? And sort of celebrate those numbers. That could have some downsides. It could have some upsides. So just be careful about what you measure and understand where the problems could lie. But if you do it right, you could build a culture of quality in your team that could really be of service to you. And peer review is a great place to do this, because it's where the rubber meets the road. It's where the technologists make things happen in the infrastructure.
In that example you gave earlier about the doctors, it was the nurses who had the opportunity to kill a procedure if a checklist wasn't followed. Is there something similar in this peer review process where someone can put on the brakes and say there's a problem here? And in a power dynamic of a junior and a senior engineer, how does that play out?
Yeah, I think, and that the power dynamic is really interesting. There has to be a balance of power in all of these interactions. So I don't know, what are some ways you could do it? Well, you could, in whatever your process is, and this is, kind of getting into an ITIL thing, but really, if you require a person to get a sign off, and once they have picked their peer reviewer, and that person has said, I'm not going to sign off on this, that creates a power dynamic right there, right? So you could do some things with that process to make sure that that the balance of power is there. And as a manager, you want the balance to be there between the person writing the change and the person reviewing and approving the change. You need that to be balanced. And so, I don't know how you'd measure it, but the requirements and the cultural expectation, you definitely maintaining the balance is probably is what I've seen work.
And just spitballing here, what about the notion of blind peer reviews?
You could do that. I've never done that in my career. To me, I don't see a ton of value in that. I've heard of it. I don't know. If you can't interact with the person who's giving you criticism, then it's going to be pretty hard to benefit from.
A cultural problem, yeah.
Right, right. And this is a whole. I mean, this right here, this kind of thing. This is the art of managing smart engineers. You can figure this out. This is the path to becoming a good leader. And I've been in cultures that are good, and I've been in cultures that are toxic, and there's some great opportunities for a manager here. Let's talk about execution. So now we're to the part where we're going to actually execute the change. I was talking to, I mean, probably everybody here has heard about the 737 MAX debacle and the accidents and such. And, there's lots of stuff going on. There are lots of software developers writing, analyses of this to apply to their world. But I have a friend of mine who's a private pilot, and he said, look, my perspective on all this is that really why have we not seen these accidents in the United States? His perspective is that there are two different attitudes about flying a plane. In the United States, the attitude is aviate, then navigate, then communicate in order of priority. In other words, fly the plane first, figure out where you're going second, and then tell everybody else about it last. Do your job, keep the plane in the air, and keep everybody safe, and then do the other stuff. In the rest of the world, it's not really that. In the rest of the world, in aviation, according to him, the mantra is more of a communicate, then aviate, then navigate. And so if you're more focused on telling the people in charge, hey, something's going on wrong here, let me give you a report and some information, your time to deal with issues in flight might be constrained for you. But I think we can kind of have the best of both worlds if we take a checklist approach to doing these things. Now, if you're in the middle of a change, then you need to be working on the change. But the problem is, especially if it's a complex change, senior leadership is going to want updates. They're going to want to know where we're at on the timeline. Is this succeeding or not? Some of the more hands-on ones are going to be, they're going to be after you quite a bit. If you built a checklist and a process and a run book that will give you this, then you can just refer to that. We're on step 17B, and we're probably going to be done in 10 minutes. You get them off your back and get on with your work. But really, an engineer needs to do the above, I would think. Aviate, then navigate, then communicate. So validation. The question is, could you prove, if you were called on the stand in a court of law, that the change you just executed didn't harm the business? Could you prove that? And just saying, no, I looked at it, it's all good. That's not going to cut it in a court of law, right? That's not validation. So this is the question of validation. How do you prove in a court of law that the stuff you did worked and it accomplished the desired result? So if you ask yourself that question, you'll come to some conclusions. So here are some potential ways that you could obtain that evidence. Kind of going with the court example, if you had to submit evidence, how would you obtain the evidence in the first place, and in what format would you submit it? Well, here's some types of evidence that you could obtain while you're in the middle of your change. Is the platform healthy and is the platform unhealthy? In the platform, I'm using the word platforms on purpose here because I want to talk about the whole machine, the applications, the servers, the network, all of it. So is the platform healthy? How do you determine if it's healthy? Well, what's the number of IGP neighbors? Is that correct? What does the NAT table look like? If you're doing a change on a branch office and you make a change and there's nothing in the NAT table, something's probably broken, right? Routing is probably not doing its job if the NAT table is just sitting there idle. So that's a potential good data point. What kind of link layer discovery neighbors do you have? Do you have the number that you're expecting, and are they the right ones? What about the lags? Are interfaces joining the lags appropriately? Is the lag itself healthy? BGP peers, are all the peers up? Are the peers that were up before the change still up? And were the peers that were down after the change, before the change, are they still down?
Yeah, and it's very easy to forget to take that baseline measurement before you begin things. And so it can be hard to know, did your change cause a problem, or was it broken before your change? It's so often overlooked.
Right. And then there's more data too. How many prefixes did I send? How many did I receive? Is that number correct? I mean, you can eyeball some pretty big problems just by looking at that number. The BFD neighbor state, do you have the number of BFD neighbors that you were expecting to have? Now this becomes interesting because when you add a new device, but you didn't add it into BFD, but the routing protocol came up anyway, well, now you've created a problem that you're not going to detect in this maintenance window. It's not going to be found for 6 months probably that thing's not in BFD. But if you have your checklist, then you will know, oh, I was expecting an additional BFD neighbor and it's not there. You can find your mistake, which you inevitably will make, and which will inevitably make it through your peer review process into the window. I guarantee it. And then, or is the platform unhealthy? Here's some things that could signal unhealthiness. Instability of any of the above, that they're not in a steady state. You got some sort of boot loop. Bad things, bigger quotes, bad things that have happened in the past are happening. I've worked in some organizations where they're entirely driven by, we had this bad thing happen, make sure it never happens again. that never went to the why is the technology not working. It's just that, oh, this bit us, so we don't ever do that again. That's potentially a good data point. It's not the only one, but it's something to look for. And performance deviation from baseline. So is the management plane looking like it did before? Simple stuff like what's the round trip time of the pings against the management plane of the device? Did they just quadruple after your change? Well, it's green, but it's not really green. Probably you probably weren't expecting that increase in latency. And the control plane. So if you did something to OSPF, or even if you didn't do something to OSPF, what do the SPF runtimes look like now? Is that normal? Does it seem like it's the right thing according to your baseline? And you compare all these things to your baseline, and then you come up with, with the data that you need for validation. But to Ethan's point earlier, what happens? So this will produce a ton of data, and now it's 2 a.m. And what are you going to do? Are you going to run through pages, thousands of lines of output to see what was broken and find the needle in the haystack? There's a lot of data, and your time and your attention are short. So the solution is make the machines do the validation. This is not something that humans were meant to do. Humans were meant to build the checklist. Humans were certainly meant to communicate with the other humans in the business. Humans were meant to construct the strategy for how to approach this maintenance. This is a problem that is squarely in the realm of the machines. So learn to master the machine and let it do it for you. And so this is a mental model that I like to use for validation. When you first get started, you have the idea of manual before and after snapshots. So this takes the form of, okay, I've got 15 show commands that I'm going to do for the state of this device. And then I'll do it at the beginning, and then I'll do it at the end, and then I'll do a diff between them. And this is something simple like bring them up in your text editor and use your diff plugin to point out the things that are different. You can catch so many problems that way before the maintenance window even closes. But it's a highly manual process. It requires you to use your fingers to pound on the keyboard and SSH into things. So then you move to the next step, which is more of an automated before and after snapshots. And this is where you could use something like Ansible to log into everything and use a Jinja template to populate a file, and then Ansible runs those SSH commands for you. Jinja puts them into a file, and then you diff the two files, and it's still a fairly manual process, but the machine is making it happen a lot faster for you. Then you start getting into more custom code. You start writing some Python. You start saying, well, I'm going to, if you're into Yang and netcomp, you could say, well, I'm going to do some netcomp work, and I'm going to figure out how many BGP neighbors I had, and I can get that back in a structured way, and that's really easy. This overcomes a lot of problems because if you do, for example, you look at your OSPF neighbor status, you get a whole bunch of data in there that's really not pertinent to what you care about. You don't care about the dead timer probably, but you care about the number of peers. When that data is not structured, it gets really hard to, you're scraping and you're regexing, and those tools are not really that reusable from maintenance window to maintenance window all the time. But once you start working with structured data coming from netcomp and Yang and restcomp and all the other methods, now it's structured. Now you can make some more intelligent stuff with tools you can reuse for the next maintenance window. After that, in the progression comes, the idea of infrastructure unit testing, which our developer brethren know how to use unit tests, and I think we're coming into the place where we are starting to need to use it in networking. Find the smallest unit that you can test, number of OSPF neighbors, what was it before, what was it after, and then continuously monitor based on those unit tests. That idea, the idea of unit testing, I think will produce some pretty good results for us in not breaking our networks. And then after that, you move into more of a full CI/CD type deployment where you're testing all the stuff in a virtual environment and then making sure it works, and then just rolling that against the production network in a fully automated fashion. But I guess my point with all this is you need to start somewhere. If you already have the manual before and after snapshots, great, graduate to automated. If you've already got automated snapshots, then graduate up to structured data and custom code. But my hope is that after this presentation, people who are looking at it will have something that they can use in their very next maintenance window. I don't want anybody to think that you've got to go learn Python before you can be diligent in your maintenance windows. It's not true. There's a lot of stuff you can do and that you're going to have to do regardless of whether you know code or not. So discipline. So my definition of discipline is that it's a willingness of a person to do something that sucks for long enough to grasp its long-term benefits. Because once you find out that the behavior that is so hard and so distasteful, once you figure out that brings benefits, then it's really just logical thought process. Of course I need to do this. It's going to bring me the benefits that I want. But until then, there's some gap in time when you have to force yourself to do something that's painful or boring or whatever. You got to do it for long enough to grasp its long-term benefits. And that's what I'm talking about when I talk about discipline. A lot of this stuff can seem like clerical work. Like, oh boy, I got to go to 15 devices, run, show IP, OSPF neighbors. It requires some discipline to do that. Once you get to the 10th device in the maintenance window and everything is still good, it's so tempting to just say, you know what, nothing could be wrong. It's all going well. In economics, we call this the hot hand fallacy, right? If I've been doing something really well and it's been going well, it's going to continue to go well into the future. It's a cognitive bias. So that's not true. And discipline is the way to get all the way to the end of that and look at all 15 of those routers, even though you really want to stop at number 12 because it all looks good and it's really late. That's the discipline piece. And then finally, the technical leadership aspect of this. So here are the 6 points that we went over. As you look at all of these, there are some great opportunities for technical leadership. And I'm not talking about if you're a manager. If you're a manager, yes, this is all very true. But I'm just talking about leadership in the context of you're someone who wants to show leadership and as an individual contributor. You can still do that. When you get and communicate context, you're helping people to understand a common vision for the change. That's leadership. But when you're planning what to do, there's definitely leadership in there, especially if you're leading a complex change with lots of engineers. You've got to coordinate their work, and you don't have any type of management relationship. There's no way for you to force what you want, so it has to be influenced, which is true leadership. In peer review, same thing. When you're reviewing somebody else or they're reviewing you, leadership is the willingness to accept feedback. Those of you who have been managers, I know about this. Execution, that's, you do the job and you do it well, and that provides something for other people to follow, especially the junior people who are watching the seniors to see what they should do and become when they're a senior in 5 or 6 years. And validation, of course, there's some great opportunities for technical leadership here. You can bring some tools into our field, into the networking industry, and we've got some great people being great leaders who are showing us the way to CI/CD and to all these other tools. A leader, somebody who shows the way. And so if you say, look, on CI/CD, that's an opportunity to lead that doesn't involve any sort of title. And then finally, discipline. Of course, it's sort of the same thing, to lead by example. So those are my thoughts. Probably not the only principles, but a lot of them. Please reach out. I'd love to discuss. If anybody has questions or anybody wants to correct me, let's have a discussion. I'd love to chat.